This video is on plotting functions, specifically speaking, three-dimensional plotting. Let me zoom out a bit. That's better. And the easiest way to access the basic functionality would be to go to plot 3D, and we have x values, which is -5 to 5, y values -5 to 5, and the expression we could either go for, or the format could either be inline, new plot, or x maxima. So first we have to select an expression. So I am going to go for x plus y raised 2. And that is the function that I get. So here, when we started, we specified that we want the format to be inline. Now here's another example where we could have x plus x times y and specify the values as is. And only this time, instead of going for inline, we could go for new plot, and it is going to give us in a separate window. Make sure that you have new plot installed, or else this particular functionality will not work. And the third option is when we could have an expression, perhaps cosine x plus sine y, and we could specify we wanted an x maxima, and OK, and we would get that. So once again, if we want this to work, we need x maxima installed, and that you can see that is the corresponding picture or three-dimensional plot of a two-dimensional function. The reason being, if you have two coordinates x and y for different values of x and y, you are going to get a function that is of x and y. So the x-axis and the y-axis would have a set of values, and you have the function that has to be plotted somewhere else, and that somewhere else would simply be the z-axis or the vertical axis in this picture. So inline is a great option, or new plot is also a great option, and you can change those here by using the plot format function. So by default, wx maxima uses wx plot 3D, but you can change it in plot format using plot format new plot, which would use the new system, and plot format x maxima would use the x maxima system. But by all means, plot 3D, it's the base function, or is the underlying 3D plot function. So let's start. Close that. Plot 3D, and we shall do x cubed plus y cubed and we specify the limits for x and y. We have x starting at -4 all the way up to +4, y starting at -10 all the way up to +10, and and that should give us that picture. Not so great, but it is a simple 3D plot for x cubed plus y cubed. I'm going to have a new function, x squared plus y squared plus 2xy. I'm going to plot it for x values from negative 10 to positive, well, let's do negative 3 to positive 3. Y values negative 5 to positive 5, and I'm going to use a function, I believe it's mesh lines color. Let's see, if it doesn't work, we could always go for describe, but it worked. So what we have here, I'm going to remove that particular command, with default mesh lines. So if we look at that picture, the mesh lines here are drawn in sort of gold or yellow. Those mesh lines are the lines that are drawn on top of the surface that we have. However, if we use plot 3D, x squared plus y squared, and we would have x from -5 to 5, y from -5 to 5, and mesh lines grid, and we specify false. Come on. That's odd. It worked with mesh line grid. Let's save this and false. Weird. When in doubt, we could always go to help. Seems like it's mesh lines color. Okay. So what we have now is that the mesh lines that we drew on the surface, it's gone. We don't have those lines drawn. We could take the same function and instead of specifying folds, I believe you could specify a particular color. So let's try black. And that doesn't respond to us, it's just giving us the default color. So perhaps we add blue, certainly is odd. I would expect it to show a color, but it is not showing. Well, let's move on. So by default we would have the mesh lines, but we could turn it off by doing false, and that's what we get. Now there is another option called grid. So what we have is x from -5 to 5 and y -5 to 5, but I'm going to specify grid, and grid I'm going to give it 10 10. So when we plot this, we end up getting something like this. You should notice the difference between this graph or this plot and the previous one. You can see the way the surface is formed. Here the squares are, or the rectangles or the triangles that we use to form the surface are larger. In other words, the way we sample the x and y axis, it's not as refined. But if I change the command and have a grid, that is quite refined, in the sense I could perhaps have 100 by 100. So that would mean I'm sampling the x-axis from -5 to 5 using 100 points. This is like using sequence in R, where you start at -5, end at +5, and you specify the number of points that you have to pick in the middle. So 100 points obviously means you're evaluating a lot of x, y pairs. So we should get a very nice refined plot, and that's what we have. And clearly the mesh doesn't look as pretty with this, so we could go back and change that by simply adding mesh lines color false. And the more points you have in your grid, the harder the rendering it's going to be. So for instance, if I increase 100 by the grid 100, 100 to 1000, 1000, depending on the computer, your Maxima might actually crash. So it takes a lot of computational time for it to evaluate. So typically in practice we don't need a grid that is, equispaced by, 100 points. It's not necessary. So let's take a different function, y times cosine 2 times x, and let us plot that from negative to pi to positive 2 pi, and y-axis we'll do it from negative pi to positive pi. Grid we will specify 50-50. Mesh lines color we'll specify false. And now I'm going to go for something called a palette. So let's first plot this and see what we get. And that's what we have. It looks like a nice bow tie, three-dimensional bow tie. So if I copy that and paste, so here what I'm going to do is I'm going to add a command that says palette and false. And that's what I end up getting. So you can see that the palette introduces color, but if you don't want the palette, in other words, you don't want a bunch of colors, we could simply have a plain graph of this sort or a plot of this sort. But what if we want to change the color of the surface that we created? We don't want it blue, perhaps we want it green. My logic tells me that we can simply go with what we did in a 2D plot, which is simply using color and calling it black. Let's see if this works. I'm just taking a huge leap of faith here. Oh, it's worked. There you go. So that is our plot, and of course we could refine this by changing the grid. So another option here is to have a palette, but we can change the options of the palette, and we could have a bunch of colors specified. Let's say we would use black, blue, red, magenta, or we'll go for purple. And we have to remove this because we are using a palette. And we are getting an error because black, blue, red, purple, those are colors. So we have to specify color followed by, it may have to be a list. So perhaps we can change that here. So I'm putting the four colors as a list, and I'm closing the plot function, and there is a mismatched parenthesis somewhere. I see it here. So like it. So it's not a valid palette. That's odd. Maybe. So let me put gradient. See if that works. Okay, that worked. So what we have is the original function, our bow tie type function, the x values, the y values, and the grid and mesh lines. We are turning it off, and we are defining a palette this time, and that palette is going to have a gradient, and the colors that it is going to use are black, blue, red and purple. So do we have black, red, blue and purple? Seems like it. We have black over here, red over there and purple and blue. So you may wonder, well, how is Maxima doing this? Well, these values are tied into the numerical values of the function, and oftentimes we can recognize those values by using a legend in a 3D plot, and that's readily available legend or in a 3D plot is a color bar. So we could simply say color bar. Let's see what happens. Or it might be color underscore bar. It's color underscore bar. And you can see, as I mentioned, these values for which the colors are assigned are not assigned at random. Rather, they correspond to the values of the function. So the values of the function here can be traced back to the color bar up here. So that color bar tells you the maximum and the minimum value. So for a very large value, close to 4, we have black, and that's what you see up there, and a very small value would also have a black, and then positive values between 0 and 4 would have red, negative values between 0 and negative 3-ish would have blue, and if it's close to 0 we have purple. And that is the purpose of a color bar. Color bar is a good practice when it comes to, it's a good thing to have when it comes to 3D plotting. So let us try one more. Two asterisk y, and x we define from 0 to pi, y we will define from 0 to 2 pi, we will have a grid 50 by 50. Let's turn off mesh lines. We'll keep no palette, so we'll just give a color and we'll give blue. So since we are not using a palette, there is no need for us to have a color bar. So we will skip that. And if you recall, we used to have the X label and Y label functions or lists or commands with a plot 2D, we could do the same thing with a 3D plot as well. So we have X label, and I will call it my x-axis, and Y label my y-axis, and Z label my vertical axis. And we also defined the tick marks on the x-axis in a specific way when it came to plot 2D. So we used the x ticks, y ticks command. We could do the same thing here. I'm going to say x ticks as 0.5. Let's do y ticks at 1 and z ticks at 0.25. And I'll show you what these mean in a bit. What did I do here? Forgot y, so it's y comma. There it is. So that is a really funny looking function. So nice in some sort of way. So you can see I've changed the labels here. I have my x-axis, my y-axis, my vertical axis, and you can see the tick marks right here. They vary with respect to the values that I specified. So the x-axis goes in terms of 0.5 increments. The y-axis is in terms of or increments of 1, and the z-axis is in increments of 0.25.